Let's start this section with a quick review. I started out by just showing you this screen, showing you the finished product, and kind of playing with switches and letting you see things move around. Then I took you in and I showed you the XML file associated with a class of signals and how I modified that. I showed you also how I modified my icons, my little graphic images here. And I told you about how I moved them to a safe location, taking them out of the JMRI file path so that when JMRI gets updated, your modifications don't get written over. Um, then we talked about, and I demonstrated setting signal heads, and then once you had signal heads, how to use those heads to configure your signal mast. Once we had the heads and mast defined, then we came back to this screen. We went into the layout editor. I showed you how to drop a icon onto the screen, kind of rotated it around a little bit. I reminded you that it was active, and I told you how I was actually watching my signals on my layout change as I clicked on the mast, and each of the updates occurred. So now we have complete logic, but all manual, and we need it to be automated. So let's move forward with that and see how to get that done. We're in the Panel Pro Tools, Tables, Signals. Since we're working signals, that's probably what you're thinking, right? Let's go into Signals and go into Signal Mast Logic. That would be true if you were using all the automatic features of JMRI and letting it discover your turnouts, your blocks, and your signal mast, and letting it develop its best scenario for signaling. Um, but since I'm not using a prototypical layout, it didn't work for me. I tried it. It was close. It tried. I'd say they've done a good job, especially if you're following the rules of a prototypical railroad. But if you click on this for mine, you're going to find out that mine is empty, that I have nothing there because I didn't follow any of the automated logic. So let's go back, go to Tools, Tables, and we'll come down here to Logics. Logics is just generic area for writing control logic. Doesn't have to be for signals. But I used it so far for my signaling since I have to write custom code. And basically, if you look here, I've written a logic for each one of my signal masts. Okay? So I have 16 of them, right? Starting with the number 1. 1 through 16 is what? Okay? So let's pick one to talk about. Let's pick E10 outer. Okay? Logics, if you leave it enabled and save it, when you start Panel Pro back up, this logic will be automatically enabled. If you disabled that, then when you start it back up, you're going to have to manually do it. So I'm leaving those checked. Okay? I haven't entered any comments yet. Under Select, you have a couple of options: Edit, Copy, Delete. Pretty self-explanatory. So we'll stick with just going into the edit mode. Again, this is E10 outer. So here you see I've created 3 conditionals for the signal mask E10 outer: red, approach, and clear. The word red is inappropriate, so let me rename that to stop. Okay? So I have all of my aspects, right? Clear, approach, and stop. So let's go into the edit feature of stop. Let's see what conditions causes stop. Okay, so the top half, all the conditions I'm checking for that would make me want to show the aspect stop. The bottom half is the action itself. Change the aspect to stop. Okay? When you're writing conditions, you have several different states that you can use. Okay? This one happens to be or. You can have an and, an or a mixed. I need an or for this one, and let's read through the table and understand why. Okay? So the first one says, turnout switch 9 is thrown. Okay? Or if sensor block 5 is active. So let's see how this makes sense for me. So if I go to E10 outer right here, okay, I'm sorry, E10 inner. Hang on just a second, let me get my bearings back. Switch 9, yeah, on block 5. Okay, my mistake. So here, if I'm coming east to west, and I come down here, if switch 9 is thrown, I'm going to have a derail. My train's going to leave the rail because I'm not coming into the switch in the right direction. So switch 9 has got to be closed before I can even use this rail. Okay. The next thing I've got to know is that block number 5 is not occupied. Okay. So if block 5 is occupied, the sensor will be active. Okay, so now we can go back to the logic. So if switch 9 is thrown, I'm going to derail. Or if block 5 is active, there's something in the way. There's something on that track. Okay? So that means I want to come down here to my actions, and I want to say, if my above conditions are true, set signal mask E10 outer to stop, and edit it. Let's see how I did that. Okay? Let me pause for just a second here. Okay, I'm back. So here I've called up my action so you can see how it was entered. Okay? So my signal mask, I said action group, signal mask. As soon as I select an action group, I get a pick list. Okay? They make it real easy for you. So I go to my signal mask table, and I find E10 outer, and I just drag it up and drop it in there. Okay? So now it knows which one I want to use. Okay? What action type do I want? So I tell it I want to set the aspect. Okay? What do I want to set it to? I want to set it to stop. Okay? And on an option, what change option? When one of my two conditions above, either one of them is true, right? Then I want this action to occur. So on change to true is left. Okay? If I hit update, that fills this line in. Of course, I hit cancel because I already have it there. Okay? So that's how you do an action. Doing a condition is much the same way. Okay, let's go up here and let's look at switch 9. We'll edit switch 9. Okay? Again, pick the variable type. Right? It can be a turnout, it can be a light, it can be a signal head, it can be a signal mask. Okay? So of course, I'm interested in the turnout, so I pick the turnout variable. Then I go to my turnout table, and I know it's switch 9, and I can review that because here on my little worksheet, see I've got it labeled switch number 9. Okay? So I now know it's switch 9, and if it's thrown, okay, if I click update, it adds it to my conditional list. I'm going to hit cancel because I already have it there. Okay, so you can just do that. It's a matter of filling in the blanks, just getting a little bit used to what you're looking at. Okay, so that's an OR gate, right? So R1 or R2. Okay, that's row 1, row 2. Okay, if either one of those is true, then do this action. Set the mask to stop. Okay, so now I'm going to cancel that. You can see that I've found my two conditions in which I need to set that mask to stop. Now, how about approach? Okay, so I call up the approach. You can see this time my logic operator is an AND. Okay, so since it's strictly AND, that means all my conditions must be true for that condition to trigger this action. Okay, so is it true switch 9 is closed? True. Okay, and block 5 is inactive. In other words, there's nothing in that block of logic. Okay, and block 3 is active. Okay, let's go back to my drawing again. We'll review this a little bit. Okay, we're coming this way, so you can see why we want to know if block 5 is inactive. Okay, there's nothing there. We want to make sure that switch 9 is closed so that we don't derail. And we want to look ahead at block 3. Do I have a train or anything in block 3? So if there was a train here, block 3 would be active. So my switch is closed, my block is not busy, but the next block is busy. So if all those are true, then I'll drop down here and perform my action. And then on change to true, set signal mask E10 outer to approach. Okay? And again, that's the same type thing. You just look over here on your signal mask table, select the right signal mask that you want to set, drop it in your box, say I want to change my aspect, and I want to change it to approach, right, when the condition goes true. Then you would update it. It adds it down here. Of course, I'm going to cancel it because I already have it in place. So you're beginning to see how I'm doing this, right? Let's close up the approach. Now, when do I want my clear aspect to show? Okay? And again, this is AND logic. So what I'm looking for is all three conditions to be true, just like they are right now. Okay? So if switch 9 is closed and block 5 is inactive and block 3 is inactive, trigger this action. Set signal mask outer to clear, E10 outer to clear. Okay? So I'm not going to go through each of those steps again, but I think you're beginning to see the idea of how to do that. Okay? Being real world and hooked up, one thing I haven't shared with you is this check state variables. I can check that, and this state will actually update to reflect the real world. And I can see if my logic should be triggering this action. Okay? However, this condition is not active when you have it open in this window for editing. But as soon as you update condition and close it up back to this level, it is now activated. So I can go out, drive a train around, and watch my signals update and test my logic. If it doesn't performed, then I can stop, go back in to edit the block that's not working. Does that make good sense to you? All right, now what I want to do is I want to stop for a second. I'm going to go through my logic, and I'm going to find a logic that has a mixed block of logic in it. I think it's worthwhile to show it to you so you can see how it's done. Let me stop. Let me pause and continue on in a minute. Okay, I kind of browsed through my logics a little bit here, and I found an interesting one that I want to share with you. E9 station, clear. Okay, this is what we call a mixed logic block. Okay, it's not completely an and, it's not completely an or. Okay, this one is using the not instruction. Okay, so let's see here. I'm using R1. I'm looking at switch 12 to be closed. R2, I'm looking for block 8 to be inactive or nothing in the block, right? And here R3, I'm looking at a signal mask. Okay, it's signal mask aspect stop. Okay, but look up here on my line, my expression line. Okay, I'm saying if row 1 right here and row 2 right here. Okay, so these two have to be true, right? Row 1 and row 2 and not R3. Okay, so R3 is checking to see if this signal mask is set to stop. We don't want it on stop for this other signal to be clear. Okay, so notice I put it in parentheses so that the not is associated with R3. So that's a good use of the not command. Now again, let me stop here and just find another little piece of logic to share with you. Here's another good example of mixed logic. If you look at the top line again up here, you'll see that R1 and R2 have to be true. And one of the three following have to be true. Either R3 or R4 or R5 have to be true. So it takes three items to make this condition true. R1, R2, and R3, or it can be R1, R2, and R4, or it can be R1, R2, and R5. Okay? So this is what you have to do. You have to go back, fall back a little bit on your math expressions and learn where you want to put your parentheses and them and or them. Remember, R1, R2, 3, 4, and 5 are referring to the row number. Okay? So remember that when you're writing that expression up there, it's the row number for simplicity that it's referring to. Okay? So these conditions have to be met before this action can be done. So with that said, I think I'm going to close this section out, let you understand a little bit more about the logic. You'll have to practice it on your own. Just get the feel for it. It's not that difficult once you start. It's a matter of filling in the boxes and learning the terms a little bit. Okay?